All right, this last video gives you examples 7 and 8, and it'll be the last ones. So we take a second to look at this one. Sine squared theta minus 7 sine x plus 10 all over sine squared minus 25 equals sine theta minus 2 over sine theta plus 5. So, looks unlike anything you've done before, but we should be able to learn from the last question we did. So the last question we did in the last video was we got to a certain stage and we said, hey, if I can do rainbow, I can factor. This was difference of squares, so I'm going to factor. So factor is a strategy that we can have at our disposal. If we look at this, this looks like something I can factor. I maybe haven't factored things with signs in it before. So one strategy is to do this. And this you might do off to the side. So I'll do it off to the side. Is notice instead of saying sine squared, I'm just going to pretend that the sign is an x. So I'm going to call that x squared. And then this minus 7 sine is like a minus 7x. And then the plus 10 is obviously just plus 10. Now it looks like something I know. Okay, so I'm sort of cheating and I'm going to put x's instead of signs just because it's something that's familiar. Now this is a trinomial. Two numbers multiply to 10 and add to negative 7. So that's x minus 5 and x minus 2. Right? So this is the scrap stuff I'm doing off to the side, but now I'm going to go back and replace it. So first things first, left side equals right side, or left side and right side. So got to recopy the question. And then the right side over here. So this little factoring that I did is I know that this thing changes. So it's x minus 5. Well, of course, it's not x in the actual question, it's sine. So it turns into sine theta minus 5. And instead of x minus 2, it's sine theta minus 2. Okay, on the bottom, maybe you can do the same strategy. See this here? It says sine squared minus 25. Well, maybe you can do this in your head, but what I'm going to do is say, okay, I can't factor that, but I can maybe look at this, x squared minus 25. Say, oh, that's perfect square, that's difference of squares, x minus 5, x plus 5. Or plus and minus, doesn't matter. So this part here changes to sine theta minus 5 and sine theta plus 5. Of course, if I look at this, I've got a sine theta minus 5 on the top divided by sine theta minus 5 on the bottom. And that leaves me with sine theta minus 2 over sine theta plus 5. And the left side equals the right side. And it is proven. All right. So again, did I expect you to do this question right away? No. Okay, maybe you learned a little bit of strategy from the last question, but I'm showing you a whole bunch so you have a bunch of experience. Again, the more you do these, the better you're going to get, because each time you're going to gain more experience and you get better at solving the puzzles. You know, if you went off and had to solve 10, 15 puzzles in a weekend, by the time you get to the 15 actual puzzle where you're putting the puzzle pieces together, you're going to have lots of experience and lots of strategies that you can use that go off and work. Same thing with this. Okay? All right. And now we get to our last one, and this is just where we start to hint at the grade 12 ones. Okay, so most of these other ones are grade 11 strategies. This one hints at a grade 12 one, and that's because it's got a secant in it. So we hadn't talked about secants and cosecants and cotangents before, so this will look a little bit different. All right. Well, what do you think the strategy is with secants? Well, just like all the other things, we're going to change things to sines and coses. Makes things easier to visualize. So I don't want to talk in secants. I want to change to coses. Remember, the reciprocal of secant is cosine. Wish it was sine, but it's not. It's cosine. So it's the reciprocal. So this means 1 over cos squared theta. Okay, if you had cos and you flipped it, you get secant. So if you have secant and you flip it, you get cos. All right, well, this is good, but it doesn't really look like the right-hand side. Right-hand side has got a tan in it. Well, remember our strategy for tans is to change it to coses and sines. So tan squared is sine squared over cos squared. So at least it's starting to look familiar. Okay? Again, always keeping an eye on the opposite side. I was working over here and I looked over here and said, oh, that's just tan. Let's change to sine and cos. Now I'm looking back. I notice that there's no sine, so things look a little bit better. At least I'm on the right track. All right, keeping an eye on this side. I notice that I have just one fraction now. Where on the left-hand side, I've got two fractions. So can I somehow change these two fractions over here to one fraction? Well, sure. I can add these. It doesn't look like it, but 1 is a fraction. So I'm going to find common denominators. This is like 1 over 1. Well, what's a good common denominator? Well, obviously cos squared is a good common denominator. So I haven't changed anything on this side, but on the right-hand side, the bottom got multiplied by cos squared, so the top must be cos squared. And if I look at it, that makes sense. So what I've essentially done is just changed 1 into cos squared over cos squared. Anything divided by itself is 1. I did that so that I could bring it together to one fraction, because I'm noticing on the right-hand side that I only have one fraction. So I got cos squared as the common denominator. On the top, I've got cos squared theta minus 1. All right, so I'm gaining a lot of confidence in this, because if I start to compare, remember I keep it in an eye, I notice that the bottoms are the same right now. So what do I need to do? I got to change the tops. And the tops is sine squared. Now, I just sort of looked ahead, and you maybe noticed this before I did. I forgot a minus sign here. That's going to be a minus. All right. So apologies there, but now you can see I forgot that minus sign. All right. Now I've got to make things look the same. This says cos squared minus 1. That looks an awful lot like the other thing that I had, cos squared minus 1, except it's 1 minus cos squared. So I got to change it up just a little bit. How do I do that? Well, you might remember doing this last year. Cos squared minus 1. Well, what I'm going to do is take a negative out, a negative common factor. So if I take out a negative common factor on the top, since this was positive, if I take out a negative, it would be a negative. And taking out a negative from negative 1 makes this a positive. So this is one of my little strategies from last year. Simplifying rational expressions. Take out a negative. I can double check that I did that correctly by just doing rainbow back. Negative times negative is positive, that's good. And negative times positive is negative, so that's good. All right, I've done it correctly. Okay, why did I do that? Well, inside the brackets, notice what I have. I have negative cos theta, squared theta, plus 1. Since I'm adding, I can either add in this direction or I can add in the other direction. So I'm going to put the 1 first, and then I'm going to add the negative cos squared all over cos squared theta. And you can tell that I had been looking ahead at this because I got a little nervous when I didn't see the negative sign that I forgot. Because now I can replace 1 minus cos squared with sine squared. It just has a negative in front. So this is the logic behind going from here to here, taking a negative common factor and then switching things around?
So I'm sure it is. I want you to take a moment to give yourself out of the